Welcome to this session of Business Mathematics. My name is Ashish Jain. I'm an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. Our today's topic is proportions. This is a brief outline of this session: problems of direct and indirect proportions, problems of compound proportion, and some numerical and word problems. Now let us take the first example. The last three terms of a proportion are 8, 12 and 16 respectively. We have to find the first term. Let us see the solution. Let the required item to be found, we have to suppose it. So let the first term be x. So the proportion is x is to 8 proportional to 12 is to 16. Since the last three values are given, we have supposed the first value to be x. From the rule of 3, we know that product of extremes is equal to product of means, that is x into 16 is equal to 8 into 12. If we solve it, we will get the value of x as 6. Hence, the first term is 6. In this way, we will find the missing terms. The second problem. The salary of A, B and C are in continuous proportion. If salary of A and C are respectively rupees 360 and rupees 490, find the salary of capital B. That means out of the three values, 2 are given to us. But to represent it in proportion, we require 4 values. So this must be a kind of problem related to mean term. Let us see the solution. Here, let us suppose that the salary of capital B is rupees x. It is given that the salary of capital A is rupees 360 and salary of capital C is rupees 490. Then the proportion is 360 is to x proportional to x is to 490. By the rule of 3, we can say that x into x is equal to 360 into 490. That is, the product of extremes is equal to product of means. Now x square is equal to 360 into 490. We have to break it into factors so that we can easily do square root. The value of x is equal to under root of 36 into 49 into 100. We know that 36 is 6 square, 49 is 7 square and 100 is 10 square. If we take a square root, our answer is 6 into 7 into 10, that is 420. Hence, salary of capital B is equal to x and the value of x is 420. The next problem. What number must be subtracted from each of 9, 11, 15 and 19 so that the difference will be proportional? We have to find the equal amount that must be subtracted from all of these values. Let us see the solution. Let the value to be subtracted is equal to x. So whatever is unknown value, we first have to substitute it. So we have substituted that value to be x. Then according to given condition, the proportion is 9 minus x is to 11 minus x. It is proportional to 15 minus x is to 19 minus x. Again, using the rule of 3, we have to multiply the mean terms and extreme terms. So we have 9 minus x multiplied by 19 minus x, it is equal to 11 minus x multiplied to 15 minus x. Just open the brackets and solve it. We will get the value of x as 3. Hence, the value 3 must be subtracted from all of the values. Now we see an example of direct proportion. A direct proportion is a proportion in which if you increase one quantity, the other quantity also increases. So we have a problem. A car covers a distance of 60 kilometers in 3 hours. How much distance will it cover in 5 hours? Here, let us suppose that the required distance is x kilometers. Here, we have more time means more distance. That means if you increase the value of time, the distance quantity is also increasing. This is an indication that this is a direct proportion. So it means that time and distance are directly proportional. We write it like this: time, this is a sign of proportionality. We also use this sign, time is proportional to distance. So for this, we have to write it in this notation, that is, we have two quantities, time and distance. It is given that for 3 hours the distance is 60 kilometers. For 5 hours the distance we don't know, so we have supposed it to be x. Now here we need to put the arrows. Here, if you increase the time from 3 to 5, obviously if you travel for more duration, you can travel for more distance. That means distance also increases. So we have to put an arrow from top to bottom. Here please remember, whenever we put arrows, we always look for the relationship, not the values of the variables. Okay. So here we write it down like this. It is 3 to 5 and 60 to x. So how do we write it into proportion? We write it like this. We always start from the starting of the arrow and we move towards the ending of the arrow. So it is 3 is to 5 proportional to 60 is to x. We know that we have a rule of 3, that means 3 into x is equal to 6 into 50. The value of x is equal to 100. That means in 5 hours the car can cover a distance of 100 kilometers. This is an example of direct proportion. Let us take another example. A person running with a speed of 15 kilometers per hour crosses a bridge in 10 minutes. We have to find the length of the bridge. A person running with a speed of 15 kilometers crosses a bridge. What does it mean? It means that in 1 hour he covers 15 kilometers of distance. Now the amount of time he required to cover the length of a bridge is nothing but the amount of distance covered in that time, which is nothing but the length of the bridge. Now let us see the solution. Here the length of the bridge is x, given speed is 15 kilometers per hour. That means a distance of 15 kilometers in 1 hour. The amount of time required to cover the length of bridge is nothing but the distance traveled in 10 minutes, which is equal to the length of the bridge. So in order to make units equal, converting hours into minutes, that means 1 hour is equal to 60 minutes. Because if we cover 10 minutes into hours, the answer would be in decimal. So to avoid that, it's better to convert hours into minutes. Now here, since the time is less, so we will cover the less distance. That means if one quantity is decreasing, the other is also decreasing. This is an indication that this is a direct proportion. Now let us see how. So we have two quantities, time and distance. If in 60 minutes we cover a distance of 15 kilometers, so in 10 minutes we cover the distance in x. That means if you decrease one quantity, the other quantity also decreases. That's why I have put the arrows in this same direction. Always remember, the direction of arrows matter, not the values of the variable. So you have to understand the relationship between the variables, not their values. Here the proportion is 60 is to 10. We always begin with the starting of the arrow and move towards the ending. That is 60 is to 10 proportional to 15 is to x. After solving, the value of x is equal to 2.5. That is, the length of the bridge is 2.5 kilometers. Here one point worth mentioning is that it doesn't matter in which direction you put the arrow, but always remember the direction should be same in case of direct and it should be opposite in case of indirect proportion. Here we have direct proportion, so the direction of the arrows is in same direction, either in top to bottom or bottom to top, it doesn't matter. If you solve the same question by putting the arrows in opposite direction, like we have the proportion as 10 is to 60 proportional to x is to 15, our answer of x would remain the same. So it doesn't matter about the values, we are only concerned about the relationship between the variables. Now the next example, this is a very good and important example. A piece of a diamond is proportional to square of its weight. If the piece of a diamond weighing 5 carats is rupees 225, find the price of another diamond weighing 9 carats. So here what is given? It is given that the price of a diamond is proportional to square of its weight. It is not just about single weight but square of its weight. And also the price of 5 carats of diamond is given to you as 225. You have to find the price of another diamond weighing 9 carats. As you can see, if we increase the weight of diamond, obviously the price to be paid increases. That means it is a case of direct proportion. Let the required price of diamond be x. Given that the price of diamond is directly proportional to square of its weight. That means if we have more weight, we have to pay the more price. One quantity is increasing, so the other quantity is also increasing. This is a case of direct proportion. So we have two quantities here, price and weight. If price is given as 225, the weight is 5, but it is proportional to square of its weight, so we have to make the square of the value 5. Similarly, since we don't know the price of the next piece, it is x, but its weight is given, that is 9, so we write it as 9 square. Now, since weight increases, so price also increases. That means it is a case of direct proportion. So we write it in proportion as 225 is to x proportional to 5 square is to 9 square. After solving this using rule of 3, the value of x comes out to be 729. Hence, the price of diamond weighing 9 carats is equal to rupees 729. Let us take another example. A piece of a diamond is in proportion to square of its weight. A diamond costing rupees 1,08,000 is accidentally broken into 3 pieces. If the weight of the pieces are in the ratio 1 is to 2 is to 3, find the loss in price due to this breakage. Now let us understand this problem. Here a piece of a diamond is broken into 3 pieces in a given ratio. So here we have to calculate, due to this breakage, what is the loss in the price of a diamond. Let us take the solution. Given the ratio of weights of 3 pieces is 1 is to 2 is to 3. So let the weight of 3 pieces of diamond be 1x, 2x and 3x respectively. Here the total weight of all the pieces is 1x plus 2x plus 3x, which is equal to 6x units. Here if the weight is less, the price is less. That means this is a case of direct proportion. Let the price of first piece be y1. Since we have already taken x, so here we are taking another variable y. So let the price of first piece is equal to rupees y1, second piece y2 and third piece as y3. Then for y1 we have price and weight. So here we put the price given in the question, it is 1,08,000, that is 108,000. But this price is proportional to square of the weight. That means we have to take 6x whole square. Also the price of first piece is y1 and the weight is x square. Now we put arrows. Here if the price decreases, the weight also decreases. That is, the proportion is 108,000 is to y1 is proportional to 6x square is to x square. On solving, we get the value of y1 as 108,000 into x square divided by 36x square. Here the x part got cancelled and the price of y1 is rupees 3,000. Similarly for y2, it is 108,000 into 4 times x square divided by 36x square, which comes out to be 12,000, and the price of y3 is equal to 27,000. Now the total price of all the pieces is equal to 3,000 plus 12,000 plus 27,000, that is 42,000. Initially the total price of single piece was 1,08,000. Now the total price of all the pieces comes down to be 42,000. So what is the loss? The loss in price is 1,08,000 minus 42,000, which is equal to 66,000. So there is a loss of 66,000 in the price of the diamond. The second most important type of proportion is indirect or inverse proportion. Let us see an example. A car covers a distance of 4 hours at the rate of 60 kilometers per hour. In what time the same distance can be covered with a speed of 80 kilometers per hour? Here the car is covering a distance of 60 kilometers in 4 hours. So let us suppose that the required time is x hours. Now here more speed means less time. If you increase the speed, you require less time to cover a distance. So if you increase one quantity, the other quantity is decreasing. This is a case of inverse proportion. It means that speed and time are inversely proportional. I write it as speed proportional to 1 upon time. This shows that this is an inverse proportion. So we have two quantities here, one is speed, other one is time. That is 60 and time is 4. For speed of 80 kilometers, we suppose that the time is x. Here we are putting the arrows. Since we increase the speed, the time required is less. That means if the direction of this arrow is from top to bottom, the direction of other arrow should be opposite direction, that is from bottom to top. It doesn't matter what is the value, you just compare about the relationship. Now the proportion is 60 to 80 proportional to x is to 4. On solving this, we get the value of x as 3. That means the car can cover the same distance in 3 hours. Next problem. If 16 men can do a work in 30 days, in how many days 20 men can do the same work? Here, more men implies less number of days. That means if you employ more people, you require less number of days to cover. Let us see the solution. Let the required number of days be x. Here more men implies less days. That means this is a case of inverse proportion. It means that number of men and number of days are inversely proportional. So we have two quantities here, men and days. 16 men can do a work in 30 days, 20 men can do a work in x days. Now we are putting the arrows. If we increase the number of men, the number of days decreases. That means both the arrows are in opposite direction. The proportion is 16 is to 20 is proportional to x is to 30. We start from the starting of the arrow and move towards the ending of the arrow in writing the proportion. On solving this, we get the value of x as 24. That means 20 men can do the same work in 24 days. Next example. 8 men or 16 boys can do a work in 39 days. That means either 8 men can do this work in 39 days or 16 boys can do this work in 39 days. In how many days will 4 men and 18 boys do the same work? So in first case, it is given that 8 men or 16 boys can do the work. But in second case, it is given 8 men and 18 boys. That means in second case, we have to consider both men as well as boys. But in first case, we can take either men or boys. Let us see the solution. Here, work done by 8 men is equal to work done by 16 boys. That means 8 men is equal to 16 boys with respect to the work done. Hence, the value of 1 man is equal to 2 boys with respect to work done. Now, 4 men and 18 boys can be reduced to 4 multiplied by 2 boys, since 1 man is equal to 2 boys plus 18 boys. That means the total answer is 26 boys. Now our question reduces to more boys implies less days. That means if you employ more people, you require less number of days. It is a case of inverse proportion. So we have two quantities here, number of boys and number of days. In such questions, we have to reduce the problem either in one quantity. Since we have men and boys, both are people, so we reduce the question either in number of men or number of boys. In this case, it is easy to reduce them to number of boys. Now, from the first, we can say that 16 boys can do a work in 39 days. So 26 boy can do the work in X number of days. Here, putting the arrows we employ more boys, so we require less days. The proportion is 16 is to 26 proportional to x is to 39. On solving this, the value of x is equal to 24. Hence, 4 men and 18 boys can do the same work in 24 days. Let us see one more example. We have a problem as 3 men and 5 boys can do a work in 7 days. 5 men and 7 boys can do the same work in 3 days. In how many days 2 men and 5 boys can complete the same work? Let us understand this problem. Here we have 3 men and 2 boys, so we have to take both the quantities. So it is given that 3 men and 2 boys can do a work in 7 days. Also, 5 men and 7 boys can do the same work in 3 days. So we have to reduce this question in terms of either number of men or number of boys. Let us see the solution. Since 3 men and 2 boys finish a work in 7 days, that means 1 day work of 3 men and 2 boys is equal to 1 by 7. That means if I take a cross multiplication, I can say that 1 day work of 21 men and 14 boys is equal to 1. Let us mark it equation number 1. Also, it is given that 5 men and 7 boys can do the work in 3 days. That means 1 day work of 5 men and 7 boys is equal to 1 by 3. That means 1 day work of 15 men and 21 boys is 1. Let us put it equation number 2. Since they both equal to 1, I can equate them together. On equating equation number 1 and 2, we have 21 men plus 14 boys is equal to 15 men plus 21 boys. That means 1 boy is equal to 6 men in terms of work done. Let us mark this as equation number 3. Now we are left with 3 men and 2 boys, or we can take 5 men and 7 boys. Let us take the first case. We have 3 men and 2 boys. So we can write it as 3 men and 2 boys is equal to 3 men plus 2 into 6, since 1 boy is equal to 6 men. So my answer is 15 men. It is given that we have to find it for 2 men and 5 boys. Again, on reducing, we have 2 men and 5 boys is equal to 2 men plus 5 into 6 men, that is 32 men. Let the required number of days be x. So the question reduces to 2 quantities, men and days. That means 15, 7, 32, x. Again, we have to put the arrows. So if you increase the number of men, the number of days required are less. That means it is a case of inverse proportion. So the proportion is 15 is to 32 proportional to x is to 7. On solving this, I get the value of x as 3.28. That means 2 men and 5 boys can complete the same work in 3.28 days. Now the most important part of proportion, which is compound or mixed proportion. A compound proportion involves repeated use of simple proportion. It contains more than 2 ratios. It is also called mixed proportion or the double rule of 3. Here the quantities to be found out are A1 is to A2. It is proportional to other quantities like B1 is to B2, C1 is to C2 and D1 is to D2. On solving, we have A1 into B2 into C2 into D2, it is equal to A2 into B1 into C1 into D1. That means the product of extreme terms is equal to the product of mean terms. Now there are some rules to solve a compound problem. The rules for solving compound proportion are: first, substitute the unknown quantity by a variable, say x. You can take any variable. Here I am taking x. Second point, write the quantity for which unknown value is to be found out either to the left or to the right side. Taking the pairs of quantities of same kind, write them in same order. That means we have to put arrows. Put the arrows accordingly. That means whether it's a direct condition or an indirect proportion in comparison to the unknown variable. Next, using the double rule of 3, we have to multiply and equate the product of means and the product of extreme terms. And in this way, we can find the value of unknown variable. Let us take an example. 15 men can do a work in 14 days, working for 12 hours daily. In how many days will 21 men working 10 hours a daily can do the same work? Now let us understand the problem. Here we have 3 quantities. First is men, second is the number of days, and third is the number of working hours. It is given that 15 men can do a work in 14 days working for 12 hours daily. We have to find in how many days 21 men working 10 hours daily can do the same work. Here the quantity which is need to be calculated is number of days. So according to the rule of compound proportion, we have to either place this at the right hand side or on the left hand side. Let us see the solution. Let the required number of days be x. Here we have 3 quantities, men, hours and days. So we have men, hours and days. That means 15 men working for 12 hours can do a work in 14 days. So 21 men working for 10 hours can do the work in x number of days. Here this number of day is the unknown variable. I have put it on the extreme right hand side. Now we put the arrows. We have to compare the quantities with respect to the unknown variable. Here the unknown variable is day, so we will compare the number of men and the number of hours to number of days. So if we increase the number of men, the number of days required is less. That means it is an inverse relationship. So if I put an arrow from top to down, we have to put an arrow from bottom to top for the days. Similarly, we will have to compare hours with the number of days. So since we work for less number of hours, we require more number of days. Hence, the relationship is inverse. So how do we write a compound proportion? We would write it as, first we have to write down the variable for which we need to find the value. Here the variable is days. So we start from the starting of the arrow and move towards the ending of the arrow. It is x is to 14. It is proportional to not just one quantity but two quantities. So we have to write both the quantities. Let us start with the men. So it's 15 is to 21 and 12 is to 10. Now on solving by using the double rule of 3, we have x into 21 into 10 is equal to 14 into 15 into 22. On solving, we get the value of x as 12. Hence, the required number of days is 12. The most important thing in solving a compound proportion problem is to put arrows. That means to identify the current relationship, whether it's a direct proportion or an indirect proportion. Let us take another example. Here in this problem, it says that in a factory, 6 workers working 8 hours a day manufacture 4 gates in 20 days. Now let us identify the quantities involved here. We have workers, we have number of hours of day, we have number of gates and number of days, that is 4 quantities. So the question says, in a factory, 6 workers working 8 hours a day manufacture 4 gates in 20 days. If 9 workers working for 10 hours a day, in how many days they will manufacture 6 gates? So what is asked? We have to find the number of days. Let us see the solution. Let the required number of days be x. Here we have 4 quantities: workers, hours, gates and days. Let us put them together. So since the number of days is to be found out, I have kept it on the extreme right. It is given from the first condition that 6 workers working 8 hours a day manufacture 4 gates in 20 days. Now 9 workers working 10 hours a day manufacture 6 gates in how many days? Now let us compare each quantity and put arrows. First I compare workers with the number of days. Obviously, since my number of workers are increasing, the number of days should be less. That means it's an inverse relationship. Again, on comparing the hours with day, we have, if we work for less number of hours, we require more number of days. That means it's an inverse proportion. So we have to make the direction of the arrows opposite. Please don't compare the values, only compare the relation. Similarly with the case with gate, if you work for more number of days, you manufacture more gates. If you work for less number of days, you manufacture less gates. That means it is a case of direct proportion. So in direct proportion, the direction of arrow should be same as that of the day. That means it should be from bottom to top. Now we write this in terms of proportion. So first unknown quantity, that is x is to 20, then all the known quantities. We have 6 is to 9, 8 is to 10 and 6 is to 4. On solving this using double rule of 3, we have x into 9 into 10 into 4 is equal to 6 into 8 into 6 into 20. On solving this further, I get the value of x as 16. That means the required number of days is 16 days. Now let us look back what we have covered in this module. We have started with the concept of proportion. We have seen the types of proportions. We have seen various important rules of proportions. We have seen direct and indirect proportion. We have seen compound proportion, and also we have covered some numerical problems on proportions. I hope this would have given you insight into this topic. Please do practice for a better understanding. Till then, happy learning. Thank you.